You've driven next to these trucks for decades, but nobody ever explained this. If you've been driving American highways since the 1960s or 1970s, and I mean really driving them, not just riding shotgun, but actually behind the wheel, hands on that steering wheel, mile after mile on -70, -80, -90, then you have seen this. You've seen it hundreds of times. Maybe thousands of times. A massive dump truck. A cement mixer. A heavy hauler loaded down with steel beams or gravel or construction equipment. Rumbling along next to you, shaking the ground, throwing wind against your car. And you glance over, the way drivers do, just a quick look. And something catches your eye. One entire row of tires is not touching the ground. They're just up there, hovering, spinning in the air like the truck forgot to put them down. The axle is there, the wheels are there, the rubber is there, but there's daylight between those tires and the pavement. Your brain does a double take. Is that truck broken? Did something collapse? Is that driver even aware that half his wheels are floating? Maybe you sped up a little just to get away from it. Maybe you mentioned it to whoever was sitting next to you. Maybe you shook your head and figured it was some kind of mechanical failure you'd never understand. But here's what nobody ever told you. That floating wheel? That hovering axle with the tires spinning in the air? It is not broken. It is not a failure. It is not a glitch. It is one of the most carefully engineered, legally required, economically calculated features in the entire American trucking industry. And the story behind it, the real story, goes all the way back to 1956. To a president who saw something in Germany during World War II. To a highway system that cost $425 billion. To a federal law that changed how every single heavy truck in this country is allowed to operate. You drove next to these trucks for 50 years. Nobody ever sat down and explained the whole thing. Today, right here on Regal Rides, we're going to fix that. Buckle up, because this story is bigger than you think. The road problem. Before we talk about that floating tire, we need to talk about what's underneath it. The road. And I don't mean that in a casual way. I mean we need to really look at what American roads are made of, how much punishment they can take, and what happens when something too heavy rolls over them. Because here's a number that most people have never heard, and when you hear it, everything about this story starts to make sense. A fully loaded 18-wheeler does 9,600 times more damage to a road surface than a regular passenger car. Not 10 times more. Not 100 times more. 9,600 times more damage. Let that sit for a second. Every car you drove in your life, your 68 Mustang, your 74 Silverado, your family station wagon loaded up for a summer road trip, all of those miles, all of that weight, all of that rubber on pavement, barely registers compared to what one loaded semi-truck does in a single pass. The physics behind this is something called the fourth power law. It was discovered by the American Association of State Highway Officials back in the late 1950s, right at the moment America was building its interstate highway system. The law states that road damage increases to the fourth power of the axle load. In plain English, if you double the weight on an axle, you don't double the road damage. You increase it by 16 times. So when a truck adds more weight, the road underneath doesn't just suffer a little more. It suffers catastrophically more. And the numbers on road repair prove exactly that. Repairing one single mile of interstate highway costs between $40,000 and $80,000. That's not building a new road. That's just fixing the damage on an existing one. In some states, California, New York, Pennsylvania, major highway reconstruction runs $1 million per mile or more. This is your tax money. Every pothole, every crumbling shoulder, every highway that feels like it's shaking your car apart, heavy truck damage is the #1 cause. And by the 1950s, the federal government knew this. They knew it because they were about to build the largest road system in human history. And they needed it to last. So they faced a question that would shape American trucking for the next 70 years. How do you let trucks carry the freight this country needs, without destroying the roads you just spent hundreds of billions of dollars building? The answer started in 1956. And it started with a general who became a president, and a memory of roads he'd seen in a country his army had just helped defeat. Eisenhower and the Highway Act of 1956. The year is 1919. A young Army lieutenant colonel named Dwight D. Eisenhower volunteers for a military convoy, a test to drive a column of Army vehicles from Washington, D.C. all the way to San Francisco. It takes 62 days. The roads are so bad that vehicles break down constantly. Trucks get stuck in mud. Bridges collapse under the weight of military equipment. The convoy averages less than 6 miles per hour. Eisenhower later wrote that the trip was an eye-opener. America's roads, he said, were a national embarrassment. Fast forward to 1944. Eisenhower is now Supreme Commander of Allied forces in Europe. His armies are pushing through Germany. And he sees something that stops him cold. The Autobahn. Germany's national highway system, for high-speed and heavy loads. Built specifically so that the entire country could move troops, supplies, equipment, quickly and efficiently. Eisenhower doesn't forget it. In 1952, he's elected President of the United States. And one of the first things he pushes for, one of his defining missions, is to give America what Germany had. On June 29, 1956, President Dwight Eisenhower signs the Federal Aid Highway Act. It authorizes the creation of 41,000 miles of interstate highway, connecting every major American city, running coast to coast, border to border. The price tag? In today's dollars, $425 billion ***. The single largest public works project in American history. If you were in your 20s or 30s in the late 1950s and 1960s, you watched this happen. You saw the construction crews. You drove the new stretches of I-whatever before the paint was barely dry. You remember when those smooth, wide highways were brand new. But here's what most people don't know about that 1956 law. Buried inside it, alongside all the construction funding and the route planning and the engineering standards, were the first federal weight limits for trucks. Because Eisenhower and his engineers knew something that the public didn't fully appreciate. Those beautiful new highways, that $425 billion investment, were fragile. Not fragile to car traffic. Cars were fine. Fragile to heavy trucks with too much weight concentrated on too few axles. The 1956 Act set a federal maximum of 73,280 pounds gross vehicle weight. They also set axle weight limits. Because they understood the fourth power law. They understood that it wasn't just about total weight. It was about how that weight was distributed. But the trucking industry was growing fast. Loads were getting heavier. Trucks were getting bigger. And by the 1960s, it was already clear that weight limits alone weren't going to be enough. The roads were still taking damage. The government needed someone to actually enforce these rules. To put inspectors on the highways. To weigh the trucks. To issue the fines. That's where the next piece of this story comes in. October 15, 1966. President Lyndon B. Johnson signs the Department of Transportation Act into law. For the first time in American history, there is a single federal agency responsible for every mode of transportation in the country: roads, rails, air, sea. And one of the DOT's most urgent early missions is this. Get control of what these trucks weigh before they destroy the interstate highway system. The DOT works with states to establish what becomes the modern federal standard, the one that is still in effect today. 80,000 pounds. That's the maximum gross vehicle weight for a standard truck on an interstate highway. But the gross weight number is almost secondary. The number that really matters, the number that determines whether your truck is legal or illegal, is the axle weight. Single axle, maximum 20,000 pounds. Tandem axle, 2 axles close together, maximum 34,000 pounds. And the penalties for going over these limits? This is where it gets serious. In most states, the fine for an overweight axle starts at $65 per pound over the limit. Not per 100 pounds. Not per 1,000 pounds. Per pound. So if your axle is 1,000 pounds over the legal limit, and in a loaded truck, that can happen easily, you're looking at a $65,000 fine. For one violation. At one weigh station. On one trip. And weigh stations aren't optional. Those facilities on the highway that trucks are required to pull into? Federal law requires commercial trucks over 10,000 pounds to stop at every open weigh station. DOT inspectors check the weight. Check the paperwork. Check the equipment. A trucking company that runs overweight trucks doesn't stay in business long. So here's the situation facing every trucking company in America by the late 1960s and early 1970s. You need to haul heavy loads. That's your entire business. Your customers need gravel delivered, concrete poured, steel moved, equipment transported. The loads are heavy by nature. But if you put all that weight on too few axles, you're illegal. You get fined. You lose your operating license. If you add more axles permanently, you add weight to the truck itself, you burn more fuel on every trip, your tires wear out faster, and you can barely turn a corner in a city. There has to be a better way. And here's where American engineering ingenuity enters the story. Because some engineer, sitting in a truck manufacturer's office sometime in the 1950s or early 1960s, looked at this problem and asked a question that seems simple in hindsight. What if the axle didn't have to be fixed? What if the driver could raise it or lower it, depending on whether the truck is loaded or empty? That question changed everything. The lift axle, the engineering solution. Picture this. You're a truck driver. It's early morning. You're at a gravel pit in Pennsylvania. Your dump truck is about to be loaded with 20 tons of crushed stone. You sit in the cab. You flip a switch on your dashboard. Somewhere underneath your truck, a set of heavy-duty airbags inflate. Slowly, powerfully, they push an entire axle downward, down from its raised position, down through the air, until the tires make contact with the pavement. You now have an extra set of wheels on the ground. Your weight is now spread across more axles. Your per-axle load drops below the federal limit. You're legal. You're protected. You drive to the job site, you dump your load, and the truck is now empty and light. You flip that switch again. The airbags deflate. The axle rises back up. Those tires lift off the ground, spinning freely in the air, and you drive away lighter, faster, burning less fuel with less tire wear. That switch, that mechanism, that rising and falling axle, that's the lift axle. And it is one of the most elegant solutions in American mechanical engineering. Here's why it works so brilliantly, and here's where that snowshoe comparison comes in. Imagine walking across deep snow. If you walk in regular shoes, your weight is concentrated on a small area. You sink immediately. But if you strap on snowshoes, your exact same body weight is now spread over a much larger surface. You stay on top. The road works the same way. The weight of the truck doesn't change. But when that lift axle drops down and those extra tires hit the pavement, the contact area increases dramatically. The pressure per square inch drops. The road takes far less damage. And the financial math of the lift axle is where it gets truly impressive. Big rig tires are not cheap. A single commercial truck tire costs between $400 and $600. A set of tires on one axle runs $1,200 to $2,400. And tires don't last forever. Friction, heat, and load wear them down constantly. Every mile those extra tires roll on pavement when the truck is empty, that's money burning off the rubber and into the road. Lifting that axle when the truck is empty saves $2,000 to $3,000 per year in tire costs on that axle alone. Then there's fuel. More tires on the ground means more rolling resistance. The engine has to work harder. On a long empty run, say, 300 miles back to the quarry after delivering a load, a lifted axle saves 3 to 5% on fuel. Across 100,000 miles a year, that adds up to thousands of dollars per truck. And there's one more reason, one that most people never consider. The turning problem. When a truck has too many fixed axles, all those wheels locked in a straight line orientation, what happens when it needs to make a tight turn? The rear wheels don't cooperate. They resist the turn. They get dragged sideways across the pavement, a phenomenon called tire scrubbing. You've probably heard it. That screaming, grinding noise when a big truck navigates a tight corner. Tire scrubbing destroys rubber. It tears up the road surface. It puts enormous stress on the truck's frame and suspension. By lifting that extra axle, the driver effectively shortens the truck's wheelbase, making it behave more like a shorter vehicle. The truck pivots cleanly through corners. No scrubbing. No screaming tires. No torn-up pavement at the intersection. One switch. One airbag. One rising axle. 3 massive problems, weight distribution, fuel economy, and maneuverability, solved simultaneously. That's not a workaround. That's engineering. How it evolved over the decades. The lift axle didn't arrive fully formed. Like most great American engineering, it started crude, got refined through necessity, and was eventually perfected by a combination of economic pressure and technological advancement. And the timeline of that evolution maps almost perfectly onto the decades of American history that your generation lived through. The 1960s, the first generation. The earliest lift axles were mechanically simple and mechanically unreliable. They used basic spring and cable systems to raise and lower the axle. Drivers had to sometimes get out of the cab to manually adjust them. They were heavy, they were clunky, and they broke down frequently. But they worked well enough that trucking companies kept using them, because even a clunky lift axle saved money. The 1970s, the oil crisis changes everything. Then came 1973. The OPEC oil embargo hits America like a freight train. Fuel prices, which had been low and stable for decades, suddenly skyrocket. Lines at gas stations stretch around the block. The government imposes the 55 miles per hour national speed limit to conserve fuel. For trucking companies, the fuel crisis is existential. Diesel costs are eating their profits alive. Suddenly, every technology that saves fuel becomes not just useful, but critical for survival. Lift axles go from being a clever legal trick to an economic necessity. Investment in better lift axle technology surges. Air-operated systems, more reliable, faster, easier to operate, start replacing the old mechanical designs. The 1980s, federal law catches up. In 1982, Congress passes the Surface Transportation Assistance Act. It raises the federal gross vehicle weight limit to the modern standard of 80,000 pounds. It also standardizes axle weight rules across all states. Before this, weight limits varied wildly from state to state, making long-haul trucking a legal nightmare. The 1982 law makes lift axles more strategically important than ever. Now that the rules are clear and uniform, trucking engineers can design lift axle systems specifically optimized around federal weight limits. The 1990s and 2000s, electronic control. By the 1990s, the air-operated lift axle has been refined into a highly reliable system. And then electronics enter the picture. Drivers get single-switch electronic controls. Push a button, the axle drops. Push it again, it rises. Response time under 30 seconds. Precise. Reliable. Effortless. Some advanced systems add load sensors. The truck monitors its own cargo weight and automatically raises or lowers the lift axle based on whether it's legally needed. Today, fully automated systems. Modern lift axle systems on high-end trucks are computer-controlled. The truck's onboard system continuously monitors axle loads. When the truck is loaded beyond the threshold, the axle deploys automatically. When the load drops below that threshold, perhaps after a partial delivery, the axle rises on its own. The driver doesn't have to think about it. But here is what is remarkable about this entire 70-year evolution. The fundamental physics has never changed. The problem Eisenhower's highway engineers identified in 1956, too much weight on too few axles damages roads, is the exact same problem being solved today. The technology got smarter. The execution got more precise. But the engineering principle behind that floating tire? It was figured out before most of you reading this were even in high school. Section 7. The numbers that prove it works. Now let's talk numbers. Because if there's one thing that separates real engineering from theory, it's whether the math actually works out. Whether the solution actually pays for itself. Whether the dollars and cents confirm that this wasn't just a clever idea, but a genuinely smart one. And with lift axles, the numbers are not just good. They are extraordinary. Let's start with road damage. We already established that a loaded 18-wheeler does 9,600 times more road damage than a passenger car. But here's what proper axle distribution does to that number. When a truck distributes its weight correctly across multiple axles, including a deployed lift axle, road damage can be reduced by up to 75% compared to the same truck carrying the same load on fewer axles. 75%. That means states that strictly enforce axle weight limits and encourage lift axle use are effectively quadrupling the lifespan of their road surfaces. In a country that spends over $26 billion per year on highway repair and maintenance, that 75% reduction represents billions of dollars in savings. Every single year. Now let's look at the trucking company's side of the ledger. A major long-haul trucking operation might run 500 trucks. Each truck does roughly 100,000 miles per year. Let's add up what lift axles save that company annually. Tire savings. Each lift axle saves approximately $2,500 per year in tire costs. Across 500 trucks, $1.25 million per year in tire costs alone. Fuel savings. A lifted empty axle reduces fuel consumption by 3 to 5%. On a truck burning $50,000 in diesel annually, that's $2,500 in fuel savings per truck. Across 500 trucks, $1.25 million per year in fuel. Toll savings. This one surprises most people. Major toll roads, Pennsylvania Turnpike, New York Thruway, New Jersey Turnpike, charge trucks based on the number of axles touching the ground. More axles down means higher toll classification means higher fees. By lifting a non-essential axle, a driver can sometimes reduce their toll classification, legally, saving anywhere from $15 to $40 per trip. A truck doing 300 toll road trips per year saves $4,500 to $12,000 annually just in tolls. Across 500 trucks, up to $6 million per year ** in toll savings. Combined annual savings for a 500-truck fleet. Tires, $1.25 million. Fuel, $1.25 million. Tolls, up to $6 million. Total, up to $8.5 million per year. From one mechanical system. One airbag. One axle that goes up and down. Now let's look at the fine avoidance side. A single overweight axle violation, caught at a weigh station, can cost $65 per pound over the limit. A truck that's 500 pounds over on one axle faces a $32,500 fine. For one stop. On one trip. A company running 500 trucks without proper weight management could face millions in annual fines. Lift axles make weight compliance not just possible, but automatic. And here's the final number that puts all of this in perspective. The cost to install a lift axle system on a truck? Approximately $3,000 to $8,000. A system that costs $8,000 to install can save a trucking company $15,000 to $20,000 per truck per year. The payback period? Less than 6 months. That's not just smart engineering. That's one of the best return on investment calculations in the entire transportation industry. Let's go back to the highway. Not today's highway. Let's go back to your highway. The one you remember from the 1960s. The one where the asphalt was still fresh and black and the painted lines were bright white and the signs were brand new green. The one where you rolled down the windows because nobody had air conditioning yet and the wind coming in at 65 miles an hour felt like the whole country was opening up in front of you. I-70 through Kansas. Dead flat. Horizon to horizon. Feels like driving into forever. 80 across Nebraska at night with the radio on and the lights of a truck stop glowing orange in the distance. 90 through the Rockies where you held the steering wheel a little tighter and the mountains made you feel small in a way that felt right. You drove those roads. You know those roads. Not as a passenger. Not on a screen. You drove them with your hands and your eyes and the seat of your pants. And somewhere along the way, on all those miles, across all those years, you drove next to these trucks. The dump trucks. The cement mixers. The heavy haulers. The big rigs loaded down with everything this country makes and moves and needs. You glanced over. You saw the wheel in the air. You wondered. And now you know. That floating wheel is the result of a president who drove through bombed-out Germany in 1944 and never forgot what good roads looked like. It's the result of engineers in the late 1950s who did the math and understood that a highway system worth $425 billion needed to be protected. It's the result of federal regulators who sat down and said, we are going to set limits, and we are going to enforce them, and the trucking industry is going to find a way to comply. And the trucking industry did find a way. They found a brilliant way. One switch. One airbag. One axle that rises and falls based on whether it's needed. A machine that adapts. A machine that thinks about the road beneath it. A machine that balances the laws of physics against the laws of the federal government against the economic reality of running a trucking company in America. You know what that is? That's American engineering. The real kind. Not the flashy kind that ends up in museums. The practical kind. The kind that solves real problems with real elegance and then goes to work every single day at 5 in the morning without anybody noticing or applauding. The highways built this country. The trucks kept it running. And the men who figured out how to protect both, quietly, practically, without any fanfare, they were doing what Americans have always done best. They saw a problem. They thought it through. They built something that worked. The next time you're on I-70 or I-80 or any of those interstates that Eisenhower built, and you look over and see a truck with a wheel floating in the air, don't wonder if it's broken. Know what you're looking at. 70 years of American engineering, compressed into one airbag and one axle. And if this story made you see something you've driven next to your whole life in a completely different way, hit that like button. That's all we ask. And if you want more stories about the America you grew up in, how it was built, how it worked, what the people who built it were actually thinking, subscribe to Regal Rides. Because we've got a lot more road to cover. And we're just getting started.